my innovation is about a guaranteed, gas-tight guaranteed biogas plant to combat the depleting cooking fuel of the developing countries. Next, please. The enormous potentials of the developing countries like Africa, Asia, and Latin America offers around 562 million cubic meter per day biogas plant out of the, say, droppings of 1765 million bovine population. And 375 million families can be benefited for cooking fuel at a zero cost in their own house and no maintenance of the plant itself. The other, say, benefits of biogas is known to one and all. I'll not narrate more, please. Now, but to achieve a perfect biogas plant, the design and the construction play a major role. All the designs of fixed dome have got three things common. One is the building material, that is the brick, sand, and cement. The second one is the configuration of a frustum of a spear or a segment of a spear. And the third one is the curing, mandatory curing. Come back to the practical difficulties which I have encountered throughout is, let's see the digester, say, construction. If you see the center, location of the center of the radius of curvature, it's above the ground, which is imaginary, and no biogas site is tabletop. So the error starts from the location of the center, and it crops up to the radius of curvature length, and then the what you call segment of the digester, which is carved out. For a while, with the naked eye, it looks level, but practically it is a little bit tilted. So it offers structural instability. Over this, the dome has to be placed, constructed rather. So the dome is again a combination of brick by brick joint, which allows lot of, say, scope for gas leakage. Once this monolithic structure comes, mandatory curing is there for 7 days, which often nowadays is ignored, optional, because the water scarcity in the villages is there. So I have offered a foolproof design in which the dome is made of LLDP, which is prefabricated and pre-tested for gas tightness and structure, and the digester is prefabricated reinforced cement concrete, that is RCC rings, which stacked up in the cylindrical portion that constitutes the digester, and eliminates all the encumbrances of those carving, finding out the location. And the life of the LLDP is around 15 years, as well as the RCC rings. They have been tested already. Since 98% of this plant is ready-made, off the shelf, so hardly it takes 3 days, and even a semi-skilled mason can complete it. And cost-wise, when I calculated and compared with, say, other countries and my country, it's working out cheap. So the opportunities are enormous in that. Please, next slide. Now, about the utilization of the grants, I would like to have a set of mold for the mold for the dome as well as the digester, and I will be building 6 demonstration plants, 3 in India, 3 outside India, where the biogas practitioners are going on, so that it will be a training cum workshop with live plants. Now, in other countries, SNV Netherlands, Aga Khan Peace Foundation, Practical Action, and many other there, whoever there, I will try to have a liaison and see that the dissemination of the technology throughout the biogas practicing countries will be changed. Last one is how to reach to the grassroots level. A chain of dissemination has to be built up. That's a nodal agency, implementing agency, plastic processor, village artisans, and then here the plastic processor and the village artisans, once they know the potential, enormous potential, obviously the competition will start, quality will be retained, and the price will be stabilized. Thank you a lot.